From my video, Graphing Polynomials for 6th, 7th, and 8th graders, I show in the beginning the function f of x equals x to the n, and I'm deriving a slope function, which is there, and a generator function, which is there. Now the slope function is a derivative, and I didn't want to show them how that was arrived at, but the Kahn Academy derived that by using binomial theorem and limits. And Kahn Academy also derived this one by using antiderivatives. But I never mentioned the words derivative or antiderivative to the students because I don't want them to think about calculus. So they just think about f, a slope function, and a generator function. And I proceed to use those definitions to do some stuff, play around a little bit with graphing. So many young students shy away from calculus because they think it is hard. I want to encourage them to take calculus, and where I do so by graphing these polynomials, I walk the students into calculus because I'm graphing the derivative of indefinite integrals, but not by those names. My intent was to give them the feeling that calculus is easy. If you look through that video, it is very clear graphically why the derivative of a constant is 0, because the slope is 0, and why the plus c in the indefinite integral has meaning, because there are multiple graphs of the integral function. I define the s as a slope and g as the area under a curve. Kahn Academy derived this formula for the derivative, which I call the slope function, using Bournulli equation and limits. They also derived this one, Kahn Academy, by using antiderivatives, where they point out the plus c. So I camouflage it by just calling the function s the slope and g the generator. Many young students shy away from calculus because they think it is hard. I want to encourage them to take calculus. I do so in my video, where I walk the students into calculus by graphing derivatives and indefinite integrals of polynomials. My intent was to give them the feeling that calculus is easy. If you look through that video, it is very clear graphically why the derivative of a constant is 0, slope is 0, and why the plus c in the indefinite integral has meaning, because there are multiple graphs. I show graphically that if you know that the differentiation of the function f of x is n x to the n minus 1, you can solve the derivative of any polynomial of type xn. But I do not mention it that way. I say that you can find the slope. The derivative is the slope of the function, sx equals nxn minus 1. I also show graphically that the indefinite integral is the area under the function fx equals x to the n, and that is the indefinite integral, but I don't call it that. I just call it a generating function. The generating function I get by integrating the function x to the n plus 1 over n plus 1. Well, I take it back by integrating the function, in which case I get x to the n plus 1 over n plus 1. The function x to the n has two other functions associated with it, namely the derivative function, the s, and the integral function, the g. By seeing both the formulas and graphical proof of simple polynomials where I use n equals 0, 1, 2, and 3, they should feel very confident about taking calculus, since most functions are just sums and differences of polynomials, sometimes in the numerator, sometimes in the denominator, where there are different formulas for that. But in any case, as long as they can differentiate, do the derivative of x to the n, they can do just about everything. As long as n, by the way, is an integer. I want to illustrate some of the graphing technique that I used. If this number right here is equal to 1, the function is equal to 1, then it's x to the 0, which is equal to 1. Take the derivative of that at 0 times x to the minus 1, or 0 over x. So it's always going to be 0 for any x. And in fact, if there was a constant times that, it's still going to be 0. So the constant of any slope, any constant, it's got a slope of 0, so it comes back down here. Now I want to go from here, I want to integrate this to see what the integral is, or what the g function is. And so we start here and move out a little bit and look at this area. and it's 1 times x. So that's the value right there, wherever the x is. Take this one right here. It's 1, it's x times 1. The value is x. And so that generates the line f of x equals x. So that's all three functions, 0, 1, and f of x equals x. So now the second case, we're going to let the function be x, and now we got to go both directions from this. So f of x equals x, the derivative is 1x to the 0, which is just 1. So that now becomes the derivative of this. And now we got to get the integral of this. So let's see how we get the integral of this. We get the integral of this by just drawing a line like so, up to, and then going up to this function here, and then we have to have that area. Well, this is x and this is x. The area of a circle, area of a triangle is 1/2 the base times the height, so it's x squared over 2. X squared over 2. And that is the integral. It's x to the n plus 1 over n plus 1. That's what you got, x to the n plus 1, which is 2 over 2. So we showed graphically that it's x to the n plus 1 over n plus 1. Now, I'm going to show you a more difficult case where this is the function and it's going to generate both the derivative and the integral. And I'll show that now. Hang on. For f of x equals x squared, finding the area under the parabola is a little more complicated. If you look at this figure, pick some point here, some value of minus x plus x, since they're both touching, it makes a rectangle. Area of that rectangle is equal to x squared times 2x, which is 2x cubed. The shaded area equals the shaded area. You can show that the shaded area here is 2/3 of the rectangle. So 2/3 of the area of the rectangle is the shaded area. Unshaded area is 1/3 the area of the rectangle. So each unshaded section must be 1/6 the area, or 1/6 times 2x cubed, or x cubed over 3. For x squared, the definite integral by formula is x to the cubed over 3 plus c, but c equals 0. So this is as shown graphically. That's it. Hope you enjoyed it.